Hello students, welcome to part 4 of the chapter Some Basic Concepts of Chemistry. In this part we are going to see about Dalton's atomic theory. So he's the same scientist who contributed to the laws of chemical combination. He was from England. So his theories was based on chemical philosophy mainly rather than specific studies. Main aim of his atomic theory was to put forward some postulates and later prove it. So it was like an approach in physics. However, he was the one who is believed to have put forward the atomic theory. Though there are a lot of controversies, still the atomic theory is credited in the name of Dalton. So according to the Dalton's atomic theory, the very first postulate is that matter is made up of atoms and these atoms are indivisible. So as we know, it is true that matter is made up of atoms, and he also stated that these atoms are indivisible. That means it is the smallest unit of matter. So as you can see here, if you are enlarging an matter, he proposed like this. So they are the building blocks. Atoms are the building blocks of almost all the matter. And the second thing he said was like atoms of same element have identical properties. For example, mass. So for example, if you are considering an element, say carbon or hydrogen or oxygen, if the element is the same, for example, if it is carbon, always they have identical properties like mass. Though during his time when he stated this, the technology was so limited and the knowledge about the chemistry is also in its beginning stage. So later it was proven that the Dalton's atomic theory in this case is not perfect. So all his postulates, what is going to tell in this part is going to be proved wrong, or at least there are some exceptions. They follow in many ways, but there are always some sort of exceptions. Though there are a lot of exceptions, it is always nice to study something that is formed as a basic. So this was the basic, and from here we will start to see the exceptions. So it's always nice to have a base. That's why we are learning Dalton's atomic theory. So in the second postulate, he said that if you have the same element, its atom, for example, if you have carbon, always the atoms of carbon are identical. Whichever carbon you see around, they are identical. So in your lower classes you have learned that it is not like this. We have isotopes of carbon which has different mass. Anyway, during that time with the limited technology, he tried to propose this. So if we have carbon, its atomic mass is 12, and he said that mass of carbon atom always has. So wherever you see carbon, that carbon atom has always the same mass of 12. The next one was that if the atoms are different, so if we have two elements, say carbon and nitrogen, their atoms will be always different. For example, again he took mass. In the case of carbon, it is 12. In the case of nitrogen, it is 14. In the case of oxygen, it is 16. So he tried to propose that all these atoms have different masses or different properties in general. Clear? Again, this was proved to be wrong because they later found out isobars. Carbon and nitrogen have some certain atoms that is having same atomic mass. Both carbon and nitrogen is having, carbon is having an atom with atomic mass of 14. Like that, nitrogen is also having atomic mass 14 here. So later they have proved it wrong, but for the time being, during his time, he tried to postulate that atoms of different elements differ in their properties. So these were Dalton's atomic theory. And the fourth one, how is a compound formed? He tried to put it like this: atoms of different elements combine to form compounds in a fixed ratio. Atoms of different element combine to form compounds in a fixed ratio. What he said was right in one sense, but they later found that there are compounds that does not have this fixed ratio. And also he mentions very specifically that atoms of different elements. But later he has found that there are atoms of same elements combining to form molecules, not compounds, to form molecules. During his time, they didn't know that the hydrogen can combine, two atoms of hydrogen can combine to form hydrogen molecule. So like this, so he never believed in existence of something like this hydrogen molecule or oxygen molecule or nitrogen molecule. So he thought that whenever atoms combine, they combine between, the combination is between different elements and they only form compounds. He never estimated that the atoms of same element can combine and form molecules of the same atoms, molecules of same atoms. He never thought like that. So this was the drawback in the, so in every postulate we can see a drawback, but as a beginning, since it is all the beginning of everything in chemistry, we have to. So this is the fourth postulate. So you can see here hydrogen and oxygen combine to form in a ratio 2:1. If they combine like that, you will get water, these atoms. And carbon dioxide, if they combine in the ratio 1:2 with carbon and oxygen respectively, you will get carbon dioxide. So this is what he was trying to put forward. So if you try to concise all these four postulates, just to recollect it, matter is made up of atoms that are indivisible, and later it was found that it is divisible. And he said that all the atoms of same element has identical property, and we found isotopes where the atoms have different of the same element have different properties. So what he stated was that atoms have of the same element have identical properties. And the third one, he said that different elements differ in their properties. This was his statement, but later we found that there are isobars having different atoms with same mass. And also he said that atoms of different element combine, and we found that atoms of same element combine. He said the combination results in compounds, and later it was found that the same elements can combine to form molecules. And he also stated that combination into compounds takes place in fixed ratio. But later they found a special class of molecules that can combine in not in a fixed ratio but in a varying ratio. And a fifth one, that is nothing but atoms can neither be created nor destroyed. So this is the first law in our laws of chemical combination by Anthony Lavoisier. So atoms can neither be created nor destroyed. During a chemical reactions, what happens? These atoms are reorganized to form different compounds. So these things are also have shown to be always not true. But one thing we can say that in many cases it is true. For Dalton's, there are always exceptions. That is the Dalton's atomic theory. So Dalton's law was perfect in explaining laws of chemical combination. And all these laws of chemical combination came into limelight during the time of Dalton. So based on this, he tried to analyze those results from the the laws of chemical combination, and Dalton put forward all these five postulates based on the laws of chemical combination. So that's the Dalton's atomic theory part.